Hello guys, welcome to another video. So in the last video we discussed about stochastic gradient descent. So in this video we are going to implement this stochastic gradient descent in Python. Let's now we are in the Jupyter notebook. First I am importing the required libraries. I am taking the salary.csv dataset, before dataset only. I am not changing that dataset. Those things are loading. We have to wait for few minutes. Okay, those things are loaded. Next I'm dividing into x and y, and I'm splitting the data into training set and validation set, not validation, testing set. So I already wrote the code for plotting and for checking the error. Just we need to work out about algorithm only. So the first thing is we need to initialize some variables. First m equal to 0.5, c equal to 0.1. Any numbers you want to, any kind of numbers you can initialize to m and c, even 1000, more than 1000 or less than 1000, even in minus also. Next we need to set the alpha value 0.01 I am giving, and number of iterations 4000. Again I am giving same number of iterations, 4000 only. Now for I in range n, and again we have to create some dummy variables, that means duplicate variables. Slope equal to 0, intercept equal to 0. Next we need to open another for loop for j in range lx. Lx means the length of the training dataset. Here is the main thing you need to remember. In the gradient descent we operated the gradient descents after completing all training examples, but here we are going to update the gradients after each instance. That means you need to update in the inner for loop those slope and intercept values. The first thing is we need to create some random value. I'm keeping random index equal to np dot random dot randint lx. So it will return from 0 to lx minus 1. Okay, next we need to calculate the slope and intercept values. First I am going to calculate the intercept values. Intercept equal to intercept plus open brackets m into x train ri to ri plus 1. Finally we have to add c, and next we need to subtract the y original, that means y train ri to ri plus 1. So we are taking only one instance from the training data set. Next intercept is completed. Next we need to calculate the slope. Slope equal to slope plus m into x train ri to ri plus 1 plus c minus y train ri to ri plus 1. Finally we have to multiply with x value, x train into x train of ri to ri plus 1. We calculated the slope also. So now we need to update the gradients. So as we did in the gradient descent method, we updated in the first for loop, but now we need to update in the second for loop. That means we are going to update every each instance. So m equal, sorry, okay, then first we take c intercept. So we calculated c equal to alpha into intercept divided by lx. Next m equal to m minus alpha into intercept divided by lx. So we are taking only one instant and we are updating the gradients after every each instant, instead of training or instead of taking all data. We have to run this cell. Now let's check our slope and m values. Slope is m, print f, intercept is c. We got slope is 11,725 and intercept is 11,724. Okay, next check our plotting also. Sorry, we need to predict. By predict equal to np dot m of 0, because m is a list here, comma x test plus c by predict. These are the predicted values. This is the plotting line. We got nearly 87% accuracy. I think we need to iterate some more iterations. We need to. And now we got 88. Okay, let's decrease our learning rate. I think why we are ending up with same values, m and slope. Did we make any mistake in the algorithm? Yeah, here we made a mistake. Sorry, here we have to slope. That's why we are ending up with same values, m and c. Oh, our line is very bad. I think we need to reduce learning rate and iterations. So now line is fitted. So we got slope is 10,000 and intercept is 25,449. Let's again increase to 1,000 more iterations. Now it is very bad. I think 4,000 is the better thing. We got 96% accuracy nearly. So let's keep it like this. We got slope 9,000. So yeah, we got same value in the gradient descent algorithm also. You can cross check these slope and intercept values. Now I need to discuss about how to implement this algorithm using sklearn library. The first thing is we need to import the library from sklearn. From sklearn dot model select, sorry, not model selection, linear model import SGD regressor. Now let's load that regressor, SGD regressor. Here I want to say something. Here are some parameters are there. One is loss, you can change the loss, you can keep the penalty. Here penalty means regularizing the models. So now don't worry about this parameter. I will explain you in more detail about this parameter in the upcoming videos, because there is an order, so I'm going through order. Here now let's keep some parameters. like maximum iterations equal to 4000, and now we keep penalty equal to none. Don't worry about this parameter, can ignore this parameter. Now next parameter is ETA 0. This is about learning rate schedule. So this helps us to does not bounce from the local minimum, not local minimum, sorry, global minimum. So it helps there. We need to set to 0.1, and next finally we have to give alpha value, alpha equal to 0.01. Now let's try to fit our model. SGD dot fit x train comma y train. Oops, we got error about dimension error. We need to reshape before passing it to the model. X train equal to x train dot reshape -1 comma 1. No, it's perfectly worked. Now let's try to predict our values by predict equal to SGD dot predict x test. Before passing x test also we need to reshape this x test. X test equal to x test dot reshape -1 comma 1. Now I'm copying this plotting, so don't need to write again. Now let's check the error also. We got 93% accuracy nearly. I think you can play with these parameters, you can hyper tune these parameters, and you can work with these parameters, and you can get more accuracy also. So this is about stochastic gradient descent. So in the next video I will discuss about the mini batch gradient descent. Thank you guys, I hope you like this video. Subscribe to my channel so you don't get any miss my videos about this machine learning playlist or any latest technologies in AI. Okay guys, thank you. I will see you in the next video.